Ever wondered how top-tier Python developers write such clean, reusable, and elegant code? The secret lies in one of Python's most powerful features, decorators. But do you truly understand how they work under the hood? Or are you just copy-pasting its syntax? In this video, we will cover Python Decorators practice questions and detailed explanations guide. Master Python Decorators with this comprehensive practice exam. In this video, we are diving deep into 30 high-yield practice questions covering Python Decorators. We'll explore everything from basic syntax and closures to nested decorators, class-based decorators, and preserving metadata with wraps. Before we jump into the first question, make sure to hit that subscribe button to level up your Python skills daily. What is the primary purpose of a decorator in Python? Option A. To perform garbage collection on unused functions. Option B. To modify or enhance the behavior of a function or class without permanently changing its source code. Option C. To convert a function into a local variable within a module. Option D. To speed up the execution of Python code by compiling it to C. The correct answer is B. A decorator is a design pattern in Python that allows a user to add new functionality to an existing object, usually a function or a class, without modifying its structure. Decorators are usually called before the definition of a function you want to decorate. They are a form of metaprogramming where one part of the program tries to modify another part of the program at compile time. In Python, decorators are possible because functions are treated as Option A. Global constants. Option B. Immutable strings. Option C. First-class citizens, objects. Option D. Private methods. The correct answer is C. Functions in Python are first-class objects. This means they can be passed as arguments to other functions, returned from functions, and assigned to variables. This property is fundamental to decorators because a decorator is essentially a function that takes another function as an argument and returns a new function. What is a closure in the context of Python decorators? Option A. A method that terminates a program's execution. Option B. A function object that remembers values in enclosing scopes even if they are not present in memory. Option C. A specific type of list comprehension used for filtering. Option D. The finally block in a try-except statement. The correct answer is B. A closure is a function object that has access to variables in its lexical scope, even when the function is called outside that scope. In decorators, the inner function, wrapper, acts as a closure by remembering the original function, func, passed to the outer decorator function, allowing it to execute that function later. Which symbol is used as syntactic sugar to apply a decorator to a function? Option A, $. Option B, and. Option C, @ Option D, hash. The correct answer is C. The @ symbol followed by the decorator name is placed immediately above the function definition. This is known as syntactic sugar because it is a more readable way of writing decorated_func equals decorator original_func single quote. Both achieve the same result, but the @ symbol is the standard Pythonic way. Why is @functools.wraps func used when creating a decorator? Option A. To make the decorator run faster. Option B. to ensure the decorated function can accept any number of arguments. Option C. To preserve the original function's metadata, such as its name and docstring. Option D. To automatically debug the inner wrapper function. The correct answer is C. When you wrap a function using a decorator, the original function's metadata, like underscore underscore name underscore underscore, underscore underscore doc underscore underscore, and underscore underscore module underscore underscore, is replaced by the wrapper's metadata by using @functools.wraps. Func. Inside the decorator, Python copies the original function's attributes to the wrapper function, making the decorated function maintain its identity for debugging and documentation purposes. How should a decorator's inner wrapper function be defined to accept any number of positional and keyword arguments? Option A. Def wrapper. Option B. Def wrapper. Args. Quargs. Option C. Def wrapper. Args. Quargs. Option D. Def wrapper. List. Dict. The correct answer is C. To make a decorator universal so it can be applied to any function regardless of its signature, the inner wrapper function must use args to collect all positional arguments into a tuple, and *quargs to collect all keyword arguments into a dictionary. These are then unpacked when calling the original function inside the wrapper. When applying multiple decorators, like at dec1 then at dec2 above a function, in what order are they applied? Option A. Bottom to top. Dec2 is applied first, then dec1. Option B. Top to bottom. Dec1 is applied first, then dec2. Option C. Alphabetical order based on decorator names. Option D. They are applied simultaneously in parallel. The correct answer is A. Decorators are applied from the bottom up, in the case of at dec1 followed by at dec2. The function is first passed to dec2, and the resulting object is then passed to dec1. Mathematically, it looks like dec1. Dec2. Func. This is an important concept when the order of operations, like logging versus authentication, matters. What is a class decorator? Option A. A decorator that can only be used on methods inside a class. Option B. A function that takes a class as an argument and returns a modified class. Option C. A class that contains only static methods. Option D. A way to delete a class from memory. The correct answer is B. Just as function decorators take a function and return a function, class decorators take a class as an input and return a modified version of that class or a new class entirely. They are often used to inject attributes or methods into multiple classes without using inheritance. What is required for a class to be used as a decorator? Option A. It must inherit from the decorator base class. Option B. It must implement the __call_magic method. Option C. It must be defined as a singleton. Option D. It must have a __reaper___ method. The correct answer is B. If you want to use a class instance as a decorator, the class must implement the __call__dunder method. This makes the class instance callable like a function. When the decorated function is invoked, Python calls the instances __call___ method, which then executes the wrapping logic. To create a decorator that accepts its own arguments, e.g., at repeat, n equals 3, you need Option A. To add arguments to the inner wrapper function. Option B. An additional outer function, a decorator factory, that returns the actual decorator. Option C. To use the global keyword inside the function. Option D. To pass the arguments using the at symbol. At decorator. Args. Func. The correct answer is B. A decorator that takes arguments is actually a function that returns a decorator. You need 3 levels of nesting. 1. The outer function that takes the decorator arguments. 2. The middle function that takes the function to be decorated. 3. The inner function that handles the logic and arguments of the original function. Which of these is a built-in Python decorator used for defining methods that don't require an instance of the class? Option A, at instance method. Option B, at class method. Option C, at static method. Option D, at property. The correct answer is C. At static method is a built-in decorator that defines a method that doesn't receive an implicit first argument, neither self nor CLS. It behaves like a plain function but belongs to the class's namespace. The at property decorator is used to Option A. Mark a variable as private. Option B. Define a method that can be accessed like an attribute. Option C. Automatically generate a database schema. Option D. Make a function run only once. The correct answer is B. The at property decorator allows a method to be accessed as if it were a simple attribute, without parentheses. This is useful for implementing getters and providing a way to perform logic or validation when an attribute is accessed or set. What happens if a decorator returns none instead of a function? Option A. The original function remains unchanged. Option B. A syntax error is raised during compilation. Option C. The decorated function name will be bound to none, and calling it will raise a type error. Option D. Python automatically uses the original function instead. The correct answer is C. Since the at decorator syntax is just func equals decorator. Func, single quote, if the decorator returns none, the variable func now holds the value none. Attempting to call func later will result in a type error. None-type object is not callable. Which of the following is not a common use case for decorators? Option A. Logging and instrumentation. Option B. Input validation and sanitization. Option C. Caching, memoization. Option D. Defining the memory layout of a C-style struct. The correct answer is D. Decorators are used for high-level logic like logging, caching, e.g., at functools.lru_cache, and access control. Defining memory layouts for C-style structures is typically handled by the C-types or struct modules, not by function decorators. Which built-in decorator is used to cache the results of a function based on its arguments? Option A. At functools.cache. Option B. At functools.remember. Option C. At functools.store. Option D. at functools.persist. The correct answer is A. At functools.cache, introduced in Python 3.9, is a simpler version of LRU_cache. It stores the results of function calls so that when the same arguments occur again, the result is returned from memory instead of being recomputed. In a decorator, the inner function can access the outer function's variables. This is known as Option A, global shadowing. Option B, lexical scoping. Option C, dynamic dispatch. Option D, duck typing. The correct answer is B. Lexical scoping, or static scoping, refers to the fact that the scope of a variable is determined by its position in the source code. In decorators, the inner function encloses the environment of the outer function, allowing it to access func and other local variables. Can a decorator be applied to an entire class as well as individual methods? Option A, no, only to functions. Option B, no, only to methods within a class. Option C, yes, it's called a class decorator and it can modify the class definition. Option D, yes, but only if the class inherits from object. The correct answer is C. Class decorators work similarly to function decorators. They are placed before the class keyword and can be used to augment the class, register the class in a registry, or even replace the class with a different one. Which decorator is used to declare that a method is an abstract method in Python? Option A, at abc.abstract. Option B, at abc.abstractMethod. Option C, at interface.method. Option D, at abstract. The correct answer is B. In the ABC, abstract base classes module, at abc.abstractMethod is used to mark methods that must be overridden by subclasses. A class containing such a method cannot be instantiated directly. When is the code inside the decorator function, the outer part, executed? Option A, every time the decorated function is called. Option B, only when the program finishes. Option C, at the time the function is defined, decorated. Import time. Option D, only when specifically invoked by the user. The correct answer is C. The decorator itself, the outer function, runs once when the function is defined, typically at import time. The inner wrapper function, however, runs every time the decorated function is called. This distinction is crucial for understanding performance and initialization logic. Without at functools.wraps, what would print? My underscore func underscore underscore name underscore underscore. Return if my underscore func is decorated by a decorator with an inner function named wrapper. Option A, my underscore func. Option B, wrapper. Option C, decorator. Option D, none. The correct answer is B. Without wraps, the identity of the original function is lost. The variable my underscore func now points to the wrapper function object defined inside the decorator. Therefore, its underscore underscore name underscore underscore attribute will be wrapper. What is the best way to maintain state in a decorator? E.g., counting how many times a function is called. Option A, using a global variable. Option B. Using a class-based decorator with an underscore underscore init underscore underscore and underscore underscore call underscore underscore. Option C. Passing a counter as an argument to the original function. Option D. It is impossible to maintain state in a decorator. The correct answer is B. While you can use function attributes or closures to store state, class-based decorators are often the cleanest way to maintain state. The underscore underscore init underscore underscore method can initialize variables, like a call counter, and the underscore underscore call underscore underscore method can update them every time the function is executed. In the following, at auth, admin, def delete underscore user, what is auth? Option A. A decorator. Option B. A decorator factory. Option C. A wrapper function. Option D. A closure. The correct answer is B. Auth is a decorator factory. It is a function that, when called with admin, returns the actual decorator that will be applied to delete underscore user. What is the result of applying at bold and at italic to a function that returns hello? Option A. An error. Option B. The order depends on the Python version. Option C. A string like less than b greater than less than I greater than hello less than I greater than less than b greater than, or less than I greater than less than b greater than hello less than b greater than less than I greater than, depending on top to bottom order. Option D. Both decorators run, but they cancel each other out. The correct answer is C. Each decorator wraps the previous result. If at bold is on top and at italic is below, at italic wraps the function first. Then at bold wraps the result of at italic. This demonstrates the onion-like layering of decorators. Is it possible to decorate a function without using the at symbol? Option A. No. It's a syntax requirement. Option B. Yes. By calling the decorator manually. Func equals decorator. Func. Option C. Yes. But only in Python 2. Option D. Yes. By using the with keyword. The correct answer is B. The at symbol is just a convenient shortcut. Manually assigning the result of the decorator function to the function name is equivalent and was the only way to do it before the at syntax was introduced in Python 2.4. What is a side effect in the context of a decorator? Option A. A bug caused by the decorator. Option B. An action the decorator performs, like logging, in addition to calling the function. Option C. When a decorator deletes the function it wraps. Option D. An increase in memory usage. The correct answer is B. In functional programming, a side effect is anything a function does other than returning a value. Decorators often introduce side effects like writing to a log file, updating a database, or checking permissions before the main logic executes. When decorating a method inside a class, what must the wrapper function include in its arguments? Option A. The self or CLS argument. Option B. The name of the class. Option C. Nothing. It's the same as a regular function. Option D. The underscore underscore dict underscore underscore of the class. The correct answer is A. Methods receive the instance self as the first argument. If a decorator is used on a method, its wrapper must be able to accept self and pass it along to the original method. Otherwise, the method will fail to access instance attributes. What does functools partial do, and is it related to decorators? Option A. It's a decorator that makes a function run partially. Option B. It returns a new version of a function with some arguments pre-filled. It's often used with decorators. Option C. It is used to delete partial memory leaks. Option D. It's a way to decorate only part of a function's code. The correct answer is B. Functools partial allows you to freeze a portion of a function's arguments and/or keywords, resulting in a new object with a simplified signature. It is frequently used in conjunction with decorators to pre-configure behavior. Which of the following is a decorator commonly used in web frameworks like Flask or FastAPI? Option A, at app.root. Option B, at app.link. Option C, at app.url. Option D, at app.path. The correct answer is A. In Flask, the at app.root decorator is used to bind a URL path to a specific function. View. This is a classic example of using decorators for registration and routing logic. How can a decorator check the signature of the function it is decorating? Option A. By reading the source code file. Option B. Using the inspect signature function. Option C. By calling the function and catching errors. Option D. It can't. Decorators are blind to signatures. The correct answer is B. The inspect module provides tools to examine live objects. Inspect signature func allows a decorator to see what arguments the wrapped function expects, which can be used for advanced validation or dependency injection. Which decorator is used to create a class method that can be called on the class itself? Receiving the class as the first argument? Option A, at static method. Option B, at instance method. Option C, at class method. Option D, at type. The correct answer is C. At class method marks a method that receives the class, usually named CLS, as its first argument instead of the instance. This is useful for factory methods that create class instances in different ways. That wraps up our 30 practice questions on Python decorators. How many did you get right? Let us know your score in the comments below. If you found this helpful, give the video a thumbs up and don't forget to share it with your fellow Pythonistas. For the full Python Decorators certification and more advanced practice sets, check out the link in the description below.